Hi everyone, welcome back to our chemistry session, and today we are going to deal with structures of atom. So in our previous chapter, atoms and molecules, we have explored what are atoms, what are subatomic particles, what is the definition of atom. We did study about Sir Dalton, some postulates, and many more stuff. We also have seen how atoms enter into the world of molecules on a brief note, and now in this chapter we are particularly going to discuss about all the atomic theories and atomic models and everything that was contributed into the field of chemistry while we were finalizing the assumptions, or while we were finalizing to convince ourselves that atom looks in this particular structure. So moving ahead, in today's lesson, we'll be having this as our following outcomes or targets that we should fulfill. We are going to identify the basic parts of atom. We are going to study protons, neutrons, electrons, which are nothing but subatomic particles. And then we are going to identify uh, atomic models. We are going to study about multiple atomic models available. Last but not least, we are going to understand chemical bonds and how those chemical bonds are helping atoms to enter into the world of molecules. With that said, let's start our today's chapter. But before understanding structure of atom, let's understand atom a little bit in more better way. And to do that, we shall get into the chapters of our previous grade, and let's review some things, some important points about matter. So with that, what exactly is matter? We know that matter is anything that fulfills criteria of mass, volume, and apart from mass and volume, it shall fulfill the criteria of occupying space. So matter is something that have mass, it shall occupy volume, and more importantly, it shall occupy space. Apart from that, we have to also remember that matter isn't continuous. And if it isn't continuous, then what exactly it was? So we have studied that matter is not continuous but particle in nature. So if matter is not continuous and is particle in nature, how is it going to help us understand the structure of atom, or how is it going to clarify our concepts of atom? So we'll be learning all that in upcoming slides, but for now on, let's see. This following slide, we understand that since matter is based on particle nature, based on the arrangements of particle, matter is divided into three types. So if based on the arrangement of particles, matter is divided into three types. Solids, particles are tightly packed. And since particles are tightly packed, uh, they have very ordered arrangement. But coming to liquids, they are not that tightly packed, but they have moderate intermolecular forces of attraction, and they have irregular arrangement. And these liquids are moderately packed, or they have little bit of amount of space to move freely among themselves. So liquids are moderately packed. Now coming to gases, they are the special cases dear. These people are very free, they have random arrangements, and they are the king of their own self. So every particle is king of its own self. So understanding this particle nature of matter is very easy. So assume this is a class filled with students and I'm a very strict teacher. So if I'm a very strict teacher, you guys wouldn't be able to move here and there, and you shall be in a very ordered manner, sitting on your places, sticking to your benches. But let's say I'm a little convenient, little friendly teacher who isn't that much strict, then you would find yourself moving here and there, and you would be little irregular in classes in terms of sitting at one constant place. And similarly, if I was not at all present in class, you would be the king of your own wish, and you would be literally roaming here and there, and you will be in a random fashion, like randomly unorganized and You would be screaming, yelling, doing your, you'll be having your utmost freedom, and same logic is applied here. So based on the particle arrangement of matter, matter is divided into three types: solid, liquid, gases, where solids have very ordered arrangements, liquids have irregular arrangement, but that is not random, because gases have very random arrangement and very loosely packed. So with that sake, let's move on to the next slide and understand the concepts of atomic theory. So what exactly is atomic theory and why do we need to study this atomic theory? So atomic theory is nothing but it is a framework. So this is a framework, and why do we need this framework? We need this for two important things. One, understand the behavior of matter, and uh, what will we do understanding the behavior of that matter? We are going to study its characteristics and feature. And second, highly important part is understanding structure of atom. So how many atomic theories are actually there? The n number of atomic theories, starting from very first atomic theory, that is theory of atomism, which was somewhere around 5th century, to nuclear model of atom. He have proposed Rutherford's atomic model. So there are multiple atomic models that have been developed in the meantime. There are multiple atomic theories that have been studied in the meantime, and each theory, each model was masterpiece in itself. So with that, let's move on to the very first theory, theory of atomism. This theory of atomism was proposed by Democritus and his disciple Leucippus. According to these two philosophers, yeah, in 5th century, Democritus and Leucippus were philosophers, and according to them, atomism theory states that matter, upon successive division, it reaches to a particular stage where it cannot be divided further. So that particular stage where matter cannot be divided further was named as atom, and this word was coined by Democritus from the Greek word atomos, that means indestructible or indivisible. So that was theory of atomism, but later there was this legendary person named Sir John Dalton who proposed the solid sphere model. So what exactly Sir John Dalton did was he made he carried out some set of experiments. He have proposed some important postulates, and people, like, you might be wondering what exactly is postulates and why did John Dalton have proposed postulates. So postulates, first understanding the definition of postulates. So postulates are those are statements that are assumed truth without the need of formal proof. So postulates are those statements which need not have any formal proof, but they are assumed to be truth. So postulates are those kind of statements. And according to Sir John Dalton, he also came out with the with his postulates based on his observation. Rather than discussing all his postulates in detail, let's see some of the most important postulate. He said atom is the smallest indivisible and he said atom is the smallest indivisible particle stage of matter. So since atom is the smallest indivisible stage of matter, he also came up with second postulate: elements same type have same atom, but different elements. Okay, let me rewrite the postulates in a very neat way, so that you can clearly understand them. Uh, yeah. So coming to his postulates. So coming back again onto the very first track, so that you can clearly get what Sir John Dalton wanted to say. So first of all, understanding the definition of postulates again. So postulate are nothing but statements that are considered facts without So as I said, postulates are nothing but statements that are considered truth without the need of formal uh, proof. So Sir John Dalton have proposed few of the most important postulates, starting with his first postulate saying that atoms are smallest indivisible particle of matter. His second and most important postulate is elements of same type have same atoms, and different elements have different atoms. Till here, things look pretty simple, but one of the most fabulous work of John Dalton comes in the next postulate that states that his work in the field of chemistry was how important his work was in field of chemistry was stated by his next postulate. His postulate satisfy laws of chemical combination. And his one of the postulates was part of laws of chemical combination. And if you're wondering what exactly am I talking about when I say laws of chemical combination, to be honest, it's not much of a rocket science, but uh, it was so important for him that he got recognized as one of the most important key persons in the field of chemistry after this work. So coming to Sir John Dalton's uh, the final postulate that satisfied laws of chemical combination and your doubts regarding laws of chemical combination, there are certain laws prepared by five different people: Lavoisier, Proust, Sir John Dalton, uh, Avogadro, and Gay-Lussac's laws of gases volume. These five people proposed five different laws that were very important for chemical combination reactions and that supported the chemical reactions. So all those laws were satisfied by Sir John Dalton's postulate, and there was the turning point of chemistry where the atom's discovery have begun. Atom was coined by Democritus. Sir John Dalton's work laid down the foundation for laws of chemical combination and atoms relation. So, based on his observation, he proposed solid sphere model, and this solid sphere model was more like a ball-like structure, and people compare it with saying that Sir John Dalton solid sphere model of atom is resembled with billiards ball that is used to play snooker. So yeah, that was Sir John Dalton's work, which in detail we have studied in our previous chapter. But next, moving to one of the core important part of this chapter, that is subatomic particles discovery and atomic models, uh, laying down the atomic models. Now the actual deal starts. Um, since we are pretty aware of subatomic particles, let's compare Sir John Dalton's definition of atom first with subatomic particles, and let's get a clarity over the definition of atom, and that is actually highly important to understand this chapter. So, what did Sir John Dalton say? According to John Dalton, what is an atom? Atom is nothing but smallest indivisible particle. So if atom is the smallest indivisible particle, then the first question that rises out is, what are subatomic particles? So subatomic particles challenge this definition. So when Sir John Dalton's definition was challenged, then comes the turning point. So we have to rewrite the definition now of Sir John Dalton, saying that atoms are not only the smallest indivisible particle, but subatomic particles are the smallest indivisible particles. Then comes a question that, okay, if atom is made by subatomic particles, then what are subatomic particles made up of? Then comes quarks, up quark, down quark, and then comes again, okay, so subatomic particles are not the smallest indivisible particle, quarks are the smallest indivisible particle. No. Then comes again, what makes up those quarks? So there are multiple questions that raises on John Dalton's definition. So when scientists or researchers or chemists, whatever you call them, when they have gathered, they have compared their studies, they have realized that atom's definition should stay as the smallest indivisible particle, but only with the addition of one more word. So respecting Sir John Dalton, let's rewrite the definition of Dalton's atom definition. So atoms are smallest indivisible. So this was Sir John Dalton's definition. So to this there was one small addition saying that they are the smallest indivisible particles that exist independently. So according to this definition, so atom concept were laid down. As per that definition, atoms are the smallest indivisible particle that can exist independently. Anything smaller than atom cannot exist independently and need a dependent partner to for its own existence. For example, electron, they are negatively charged. They cannot exist independently. They need proton to have that stability. For example, protons, they are positively charged. They cannot exist independently, and they do definitely need an electron to exist independently. And from there on, there was a clear differentiation between subatomic particles and atoms definition. So with that, let's note down our final summary. So summary is atoms are smallest indivisible independently existing particles, but subatomic particles are smallest than atom and can't exist independently. So that was the summary on atoms definition. Who have ever thought that studying atoms definition would require this much of clarity, and who have even thought that we were so unclear with the atoms definition till all those researchers have worked on it. Now coming back onto subatomic particles. What's up with these subatomic particles? How many subatomic particles are present, and what is the deal with studying the subatomic particles? So scientists have studied the subatomic particles, they have observed them, they have is pointed out many postulates, assumptions, hypotheses, and after a rigorous study of these subatomic particles, they have come upon to atomic models, and today we have our own atomic model, which we have convinced ourselves to believe that okay, this is our atomic model. So there are three fundamental subatomic particles. The first one is proton, the second one is neutron, and the third, last but not the least, is electron. Starting with the last but not the least, electrons, these are negatively charged, negligible mass. Neutrons are neutral or chargeless, and they have mass. Coming to protons, they are positively charged and they also do have mass. So that's all we know in the subatomic, like in our previous chapter, atoms and molecules. So we also did study about what charge they have, what mass they have. We have studied all that. But for now, let's conclude the topic of subatomic particles right here and get into the discovery of subatomic particles one by one. Coming to the very first